all, before I introduce myself, before I get started, I just want to thank every one of you for taking time out of your day to come to my presentation. I'm very grateful for it. Second of all, I'd just like to say thank you to Mr. Combs for giving me this opportunity, allowing me to present and pursue my passion, and getting this whole thing set up. Without further ado, let's introduce myself. So this is me. My name is Abhi Vemulapalli. You can call me Abhi for short. I actually got started in CS, in computer science, in 6th grade. I continued on and entered the world of cybersecurity in about 8th grade through a little competition called Cyber Patriot. We got a team here at Grandview. We placed top 12 in the nation out of thousands. Hashtag shameless plug. You should join Cyber Patriot if you're interested in this kind of stuff. We're pretty good at what we do. I also have a couple of certifications, and one that comes to mind, or two that come to mind for me, are the CCNA and the OSCP. The CCNA is actually the Cisco Certified Network Associate, and so Cisco actually creates enterprise-level networking gear like routers and switches. And I learned how to configure them with the CCNA. And then the other certification I have is the OSCP, and that's the one that I'm most proud of. And for the OSCP, it's actually a 24-hour exam. You heard me right, 24 hours. And in that 24 hours, I have to hack into 5 different machines and gain user and administrative access. It's really difficult, one of the hardest certifications out there. Really proud that I got it. And then on top of that, I've competed and ranked in multiple CTFs, capture the flag competitions. Those are, again, hacking competitions, things like that. And lastly, next year I'm planning on attending Georgia Tech. I'm going to do computer engineering there. I'm hoping to, with a focus in cybersecurity. And with that, project overview. Before I get to the really fun stuff, the code and all that, I have to go through some boring things that Mr. Combs over there is forcing me to do. I'm really sorry about it. I really don't want to do this. I want to get into my project, but bear with me. So first of all, my primary goals. What am I doing? What am I trying to do? Primary goal, identify a zero-day vulnerability in a web browser. You're probably thinking, what the heck does that mean? A zero-day vulnerability is basically just a bug in a piece of software that developers don't know exists, but hackers in the wild are actively using that to exploit said software. And I wanted to focus and do it in a web browser, particularly Firefox. But here's the thing, I'm not that smart, I'm pretty dumb, and I knew for a fact when I was getting started, I would not find a bug. It's insanely hard. It takes people years, like 2 to 3 years, maybe if not more, to find a small bug in a web browser. So I built in a secondary goal into my project. I wanted to develop a fuzzing tool. And I'll go more into depth about what a fuzzer is later on, but high-level overview, it just takes random data, submits it to the program, and hopes that it crashes. And it finds bugs that way. Moving on, I had to create a theoretical company, so I called it Firehound, as you can see right here. Fire comes from Firefox, and Hound actually comes from Bloodhound. And Bloodhound, what they do is they try to find things, and that's what I'm trying to do. I'm trying to find a bug. Shout out to Declan for helping me come up with Firehound, actually. I didn't know what a Bloodhound was until Declan told me. And then this logo right here, I worked with the design department because I am in no way creative. So I actually reached out to a friend in the graphic design department, Alex Nishida. Awesome dude. Great to work with, and I worked with him to create this logo up here. It's a modern, sleek design, as all companies have nowadays. On top of that, it's actually blue to represent security and intelligence. After all, that is what I'm trying to do. And on top of that, purple for cutting edge, because a zero-day vulnerability, it's pretty brand spanking new. Nobody's found it before. That's the definition of cutting edge. Inspiration. Live Overflow. I watch a lot of YouTube. Live Overflow is a great YouTuber. He has a ton, of great hacking resources. One of his videos was actually about how to get started in browser exploitation. And I was like, oh, that's cool. That made me curious about it. I'll go watch it. And it made me more curious about it, and I was like, I'll pursue it in this class. I also had a love for cybersecurity. I still do. This is what I want to do when I grow up, so I thought this project actually lended. It went hand in hand with what I wanted to do. With that, final outcomes, what I wanted from the project to present to you guys. Best case scenario, I could proclaim to the world, hey guys, I'm smart. I found a bug in Firefox. I found a functional browser exploit. And then worst case scenario, I'm not that smart, but I'm still smart enough to write a fuzzer. one that's actually functional and actually attempts to send random data and fuzz the program. I also had a couple objectives that I wanted out of this project. To begin with, I just wanted a deeper understanding of computers. I geek out about that kind of stuff. As I was going through this, I learned a lot more about how computer programs run, and it was just really cool to learn about. I could spend days talking about it, but you guys would probably be bored and hate me by the end of it, so I'm not going to bore you with that. The other thing, I wanted to practice exploitation skills. Up until now, I've really only used other people's exploits, never really made my own. So I wanted to take this opportunity and see how that world went. Top of that, I wanted to evolve my presentation competency. Now, this topic is super technically advanced. Not everyone here will understand it. And so what I'm hoping to do with my presentation is present it in a way that it makes sense to you guys. And then lastly, understand the mindset of a security researcher and develop that kind of research ability, because security research is another thing. It's a small subsection in the cybersecurity field, and I wanted to explore it. And then here are my expert advisors. First of all, I'd love to thank them. They were really influential in helping me get to where I am today. I wouldn't have had like a really good project without these guys. Over here is Ned Williamson. He works at Project Zero at Google, and what they do is they find zero-day vulnerabilities in popular software, what I'm trying to do. And Mr. Williamson here actually got his job at Project Zero by doing what I want to do, is finding a browser exploit and writing a fuzzer for it. And thought he'd be a pretty good fit, given that's exactly what I want to do. Over here we have Renee Garg. He was a great help at the beginning. He works at Amazon, he's a CMU alum, and one of his master's projects was actually writing a functional browser exploit, so his expertise would have been great as well. But the issue is, near the end, he got very busy, so he was unable to help me, but I'd just say that he was great at the beginning, really helpful. Now we move on to support advisors. Excuse me as I grab a drink. Sorry. But first up is Tabby Turner. He's my best friend. He's one of my best friends from STEM. I went there 8th and 9th grade. He was really there for motivational support. Then we have Vincent Fazzini. He's not here. He had to go to FBLA, which kind of bummed him out, but he was there to help me to provide grammatical support, make sure what I was sending to Combs wasn't garbage, so that he could actually read it and understand it. And then we have my parents. They were really emotional support. A lot of other people here had their parents as financial support, and their projects were like thousands of dollars. I'm pretty sure their parents hate them after that. My parents still love me because, they didn't have to spend a single penny on my project. They were there for when I went to them crying because my stuff was not working. And with that, let's get to my project timeline. Let me tell you, let me preface this with, when I originally started, I thought I wanted to do some data analytics. I wanted to collect data on like what kind of bugs are frequent, how frequently they're found, what kind of bugs are found, things like that. I quickly realized I did not want to crunch numbers. So I switched it. And now my first step that I wanted to do, instead of collecting data, was actually understand how exploitation works on a computer. There's multiple different kinds, and I don't want to bore you guys with the super technical detail. If you're interested, just come over by my table and I'd love to explain a little bit more. With that, whoops, my second step is you'll see that it's the same as before, but I just moved it to my first step. And then my new second step was to actually write a fuzzer. And in order to do that, I had to watch a couple of YouTube talks on how other people wrote their fuzzers, and I realized that there's not just one kind, there's multiple kinds of fuzzers. So I had to research a little bit into that and how to get started with writing one. After that, my third step, which didn't change from my old plan to my new plan, is to just read the source code of Firefox and try to debug the browser, understand what's happening internally at a lower level, and try to find a bug. And now we get to the actual juicy part, my initial work and my research. So before I keep going, you guys probably need to understand how browsers work. They're not as simple as you think. They are incredibly complicated, almost as complicated as an operating system themselves. First things first, what happens with a browser is it's actually consistent of two parts. There's a child process and a parent process. Now the parent process is what you interact with. It's the URL bar, it's the closed window, whatever it is, it's what you interact with as a user. The child process is actually when you browse to a website in a new tab, say google.com, it spawns a new child process. And how many people here know what JavaScript is? Okay, cool, so there's a decent amount. And so JavaScript is just code that websites use to make their websites interactive. And that JavaScript code is executed in each individual child process by something called a JavaScript engine. The JavaScript engine just takes that JS code, compiles it down into machine code that the computer can understand, and executes it. Now this is where the fun begins. Most security researchers get their start here. They try to find a bug in the JS engine. If they're successful in that, they'll get code execution in that child content process. And what that means is they can just execute whatever code they want. Thankfully, most modern browsers now implement something called sandboxing. Now, sandboxing basically builds like a small box around each child process so that it can't access computer resources it's not supposed to. So say like files or execute other programs, things like that. The sandbox also prevents child processes from communicating with each other. But at the same time, there are a couple things that a website will need to do, like writing to a cookie file on your computer so that it can save your login or things like that. In which case, it asks the parent process to do that for it. And the way that works is it asks it through something called the IPC layer, which is the inter-process communication layer. And that's just ways of having the child process talk to the parent process. And this is where that second part of fun begins and where I wanted to focus my efforts. Is I wanted to find a bug in this IPC layer so that I could access the parent process and just escape the sandbox, even though theoretically it's supposed to protect that child process from anything, right? I wanted to find a bug that made it so that I could still escape it. And most browsers actually have different implementations. Firefox, its implementation is called JS Actors. Chrome has an implementation called Mojo. Each browser implements it differently. I wanted to focus on JS Actors. And then the other thing I researched was fuzzers. And again, like I said, fuzzers are basically pieces of software that try to find bugs in other pieces of software. It's great. This diagram up here is a VM-based fuzzing technology. That's really used for really complicated pieces of software, like a web browser. At a high-level overview, the way it works, it takes a picture, so to speak, of the process's memory, what it's executing, things like that, and then it sends in random input, and then it checks, did it reach a new layer of code? Is it interacting with something else entirely? If it is, great. It'll just randomly choose new input and send that in. And it'll keep doing that until it detects a crash. The moment it does, it outputs every single piece of data out into a file so that you can trace it back. That could be from the process information, like what's in its memory, what it was executing, plus what exactly caused the crash. After that, it restores it. Restores the snapshot, this one up here, so that it can redo that entire process and make sure that what it found was not a fluke and that it is indeed reproducible. After that, before I could actually get to work on Firefox, I had to download it. I had to set it up. And the way that Firefox actually hosts their code so that multiple people can code on it and stuff like that, is through something called Mercurial. And Mercurial is a version control system. I didn't really need to learn much about it. I just needed to know how to download it. After I did that, the source code itself was about 8 gigabytes. So 8 gigabytes of text, absolutely nothing else. When I tried to compile it, which is to say like make my own version of Firefox, it went up to 19 gigabytes. So as you can tell, browsers are very complicated. It's not very simple. And you can on the right side here, you can see like all the different folders, and that's not all of them. There's still more. I just took a screenshot of a couple. Don't want to scare you guys too much. But I had to go through a lot of those folders to find what I needed. It was painful. The other thing, compiling a custom Firefox, all I had to do was run this simple command and then let my computer heat my room as I went to sleep, because it took hours to build. And I also run a MacBook, so, overheating is a thing. After that, I could finally start to audit the source code for Firefox. And so first up, before I have to show you the code, I'm going to try to make it as nice as possible and show you guys a video of me interacting with Firefox. So on the left side over here, this is a Firefox that I downloaded from Mozilla. That's like their official stuff. And over here, you'll see me. This is what a child process. This is code that a child process would ideally send. I'm running it in something called a browser content toolbox, just so that I can impersonate a child process. And the code that I'm typing right here, it might be a bit hard to see, but I'm getting what's called a JS actor. And once I get that JS actor, I can tell that JS actor, the parent actor, like, hey, could you open up a prompt for me? And you'll see right here, that's a prompt, right? You guys have probably seen this before multiple times, but internally, that's how Firefox works. A child process asks the parent, hey, could you give me that kind of photo? And right here, that was a different kind of prompt that you could ask it to do. And now, I'm doing the same thing, but in a different Firefox. This time, this Firefox is a custom-built Firefox. What that means, it has custom code. It has code that I put in there so that I can see more data, so that I can understand Firefox a little bit more. So if you give it a little bit, I'm doing the same thing, so it's trying to open a prompt. And you'll notice in the last Firefox when I opened it, you guys actually saw a prompt open. But if I do it here in a little bit, I hit run, you'll see I got the same output, but no prompt showed up. The reason for that is because I told Firefox to hide it, and I'll explain a little bit why in a little bit. But you'll see here, this is the terminal output for my custom-built Firefox. And all of this information is stuff that I'm outputting. Like, I'm telling Firefox to output, and it's just data that like the IPC layer is sending between the child process and the parent process. The next video I have is actually me attempting to replicate a public sandbox bypass exploit. So this is actually from 2019. This was a vulnerability that someone found about 3 years ago. And right now, I downloaded their exploit code, and I'm starting up a super simple web server just to host the file so I can access it. And then afterwards, on this right side, this is just the most modern version of Firefox that I could download. I just downloaded it, and right here, I'm doing the same thing I did in the last video. I'm opening up a prompt, telling Firefox, hey, I want you to open up a prompt, and I want you to open it up with this URL I'm about to supply. You'll see in a little bit that I'm actually about to enter in, I'm entering in the title that I wanted to display, and now I'm entering in a URL that I wanted to open up to. And you'll notice in a little bit, once I run it, it's going to pop up a prompt, and nothing else happens. That's the expected behavior. That's what's supposed to happen. But now on this side, this is an older version of Firefox. It's customly built by the person who made this exploit. There's certain things that it needs, and I didn't want to spend hours trying to figure out exactly what I needed to change because it's a lot. And so here, I'm doing the same thing, sending a prompt, and I'm telling them, hey, could you open up this URL? And this one's going to be different, and this is the end game that hackers are trying to get at. So right here, you'll see me being impatient. I thought it didn't work, so I'm like, hey, I'll run it again. You saw that little thing that just popped up? That was it opening up the prompt. And in a little bit, you'll see the calculator app opens. And so that's not supposed to happen. Basically, what that means is the browser, the person, just browsed to a website, and all of a sudden, the calculator app on their computer opened up. That's not supposed to happen. Hackers are not supposed to browsing to a website should not open up programs on your computer or be able to read your files. So in that second case, a hacker had access to your system, and they could have read any files they wanted. So that could have been tax documents, anything you have stored, or run any program. And that's the end goal that most hackers are trying to get at. And so here's the scary part that you guys probably don't want to see. And this is just the code that I exploited in that last video. So over here, this is code from a JSM file. The specific file is prompt_parent.jsm. And all that means is that this JavaScript code is running in the parent process. And so this prompt open, when the parent receives that message prompt open from a child process, what it's going to do is it's going to go here and it's going to see hey, in the data that you sent me, do you have a URL? Did you supply a URL? If that is the case, then it's just going to open up a new modal window and browse to that website. And that's where the exploit actually happened, right? So this URL could be hacker controlled if a hacker had compromised the JS engine process. And then at impersonating a child process, if they ask the parents, like, hey, open up this prompt and go to this website, they can supply a website that they control. And when the browser goes to that website, it will just load their malicious JavaScript code, and they have access to your computer. We don't want that. And so right here, you'll see that this is the vulnerable code, and then this is the outdated code in like the modern version of Firefox. You'll see here, if you look here, there's no reference to a URL. They completely removed this URI thing because it's unnecessary, to be honest. But that's just an example of a previous exploit that Firefox had. And the reason I was doing this was I just wanted to know how sandbox bypass exploits work. After that, altering Firefox. So you guys remember when I was in that first video, when I tried to do the prompt in that custom book Firefox, it didn't show up. And the way I did that is, if you look at the code over here, this is again in the prompt parent.jsm, and you see that there's dialog box open, and then down here services.ww.openWindow. You know, when I opened up that prompt, you guys saw like a new window, like a system thing opening up. I was like, hey, it says open. Maybe that's what's opening up the prompt. I'll comment it out and hope it doesn't break. Good thing it didn't break, so I didn't have to spend days debugging it. The other thing is, JS actors are also implemented in a lower level, the C++ code. So in that previous video, one of the things that I invoked was something called send query. I'm going to preface this, I don't know C++. I basically came up with this from prior knowledge and just researching. This was also where I ran into a couple of setbacks. I could not get this code working at first, and I couldn't output like the data of what messages were being sent. But essentially, this function right here is run every time a child process does send query. And so I just put in my code there, and the reason why is so that I can just get a deeper understanding of Firefox. I can interact with it naturally, but also collect data on how it's working internally and just learn about it that way. And now, the fuzzer. The first function, it's not that scary, fuzzers aren't that scary. My first thing that I did was I wrote a function that just randomly generates input. So based on the type that is applied to the function, whether it be a string, an integer, or a float, which is just a decimal, it will just randomly supply of a random length. So right here it's about 100,000. So it'll just supply a string of 100,000 characters that's just completely random. And the whole point of this is to just see if I can break the program. And the other thing I had to write is a fuzzer grammar. And that basically just defines what kind of things to send, what the fuzzer needs to send to JavaScript and what it needs to test. So if you look here, this is just a dictionary. It's just a way of storing keys and values. And if you remember from that prompt open demo I was talking about, I had a title as one of the data values. And here I have string. And that string is just basically like, all right, it's telling my fuzzer, all right, when you get here, just input a random string and then send it in. And so with this, I can make this as extensible as I want. I'd go in and add as many actors, as many messages that I want to add. And I could do that, but the issue is I need to understand how those actors work, and just trying to read the source code and figuring out from that was really hard. I tried to do that with picture-in-picture. It didn't work, and that's where altering Firefox actually comes in handy, because I was hoping that I could then get more information that way. The third thing was clearly just connecting those two, the random input generator and the grammar. This is the part that actually sends in the data, so it's just a while loop that loops forever, and it just goes to the dictionary, puts in random input, and then just sends it into Firefox, exactly like how I did in the videos. A couple closing thoughts. I wasn't able to find a bug. Like I said, when I first started, people spend 2, 3, 4 years trying to find a bug, and I only spent a year. But it's a great stepping stone for me, because from here I can expand my fuzzer, I can write more grammar once I figure out how the C++ implementation of Firefox is. And then with that, I can also try to write a coverage-guided fuzzer or like a VM-based fuzzer so that it goes and like learns kind of. And then the last thing is just understanding more of the IPC implementation, just being on understanding how Firefox works a little bit more. And the last thing I want to leave you guys with is actually the security standing of Firefox related to Chrome. An article by Medallion was released pretty recently, actually, and I just read it because I was pretty interested in it. TLDR, Firefox isn't as mature as Chromium when it comes to its sandboxing methods, and it goes really into depth why it is like that. Needless to say, don't be afraid of using Firefox. It's really hard to come across these bugs, so just don't worry about it. But Firefox is slowly catching up to Chrome, so that's that. And with that, that's my bibliography. This is my bibliography. Do you guys have any questions? No, I wasn't able to. You know, it's, like I said, really hard. But I'm hoping to continue working on this over the summer and in college and see if I can find an actual bug. I'm going to still work on my fuzzer. I'll try to publish my fuzzer so that other people can help me with it as well and try to make it a bit more complicated rather than how simple it is. Okay.
How many people do you think have the OSCP?
In the world, that's a really hard question to answer. I'm not sure off the top of my head, but I can say the number of high schoolers that have it is probably in like the tens or hundreds.
Do you think in total it's less than 100,000?
Probably. That sounds about right, yeah. Yeah.
As someone who can hack into things, what is the best way for us to protect ourselves?
Biggest thing, don't reuse passwords. Second thing, don't use really easy to guess passwords. Try to make your passwords as secure as possible. Replace like letters like I with one. Just try to make a hacker's life as hard as possible. The thing with most people is, no offense, but none of you are interesting to hackers. I mean, even I'm not. You know, they're after politicians. They're after movie actors. They're after like the big people. So they're not really going to spend too much time on you, but it doesn't hurt to follow security practices. Just secure your passwords, don't write them down, don't store them, just basic stuff like that. Henry?
What's the procedure if you did find one? Do you report it to a general forum or the company directly?
That's actually a really good question. So once I find a bug, there's actually two things I could do, depending on the kind of person I am. If I want to see the world burn, I could sell it on the black market to malicious hackers for like millions of dollars and be like, yo, if you want an exploit, here you go, just use it. The other thing I could do, if I'm a nice person, is go to Firefox themselves and be like, hey, I found a bug. Could you fix this so that people don't get hacked? And the great thing about companies like Mozilla and Google and other companies that are jumping on this bandwagon is they're participating in things called bug bounty programs. And what that is they open up software, their websites to the public and be like, hey, try to hack this. And if you can find a bug, we'll pay you. And the thing with browser exploits, if you find a full chain exploit, so that's to say a JS engine exploit and a sandbox bypass, it can go up to $500,000. Companies can pay you up to that much. It's really crazy the amount of payout, like the prices that people give you for finding bugs. Yeah.
What kind of person are you?
I am the second kind. So if I found a bug, I will be responsible and tell Firefox, like, hey, can you fix this? That's what I want to do. It's actually a section of hacking called white hat hackers. So when you think of hacking, the social stigma is of black hat hackers. So, you know, they're on the dark web, sitting in their room, lit up, dark, lights off, hacking away, stealing all your data, whatever. But then there's white hat hackers. And those are hackers hired by companies to find security vulnerabilities like in your computer network, your programs, whatever it is. And I want to be in that second part. I want to be a white hat hacker.
All right, well, thank you. With that said, we'll go ahead and get the last